I think I'll start a little bit early because the room is packed and there's a lot of people on eating, so let's start early. I'm Gard. I work at Schibsted, and I'm going to speak about how we are using Spinnaker and what kind of problems we have and what works well, and give you some experience reports from Schibsted. We are a European company, and the history of the company is to start like online by buying and creating websites all over Europe, mostly, and some in Southern America, and all of these websites were created as autonomous websites, so they were independent and had all their own infrastructure, their own developers, their own entire company was totally independent of the rest of the company.
Hey, Gard, can you speak up a little bit?
Yeah.
Okay.
So, like 3 years ago, Schibsted decided to kind of join efforts with all the daughter companies and create an umbrella organization on top of this and try to move the company into one shared kind of platform or share resources so that we don't reinvent the same things in hundreds of websites. It's more efficient. So that's a big challenge. One of the things to do to share infrastructure is to move to AVS and not have all these local data centers and everything. And when working with AVS, we started to have like a lot of different ways of handling AVS deployments. Many teams used GARD, but we needed to create a continuous delivery tool for Schibsted. And some of the leaders were, I think they were visiting this office and speaking with Andy. And they set up a VC with Andy in late 2015. And we had this offsite in Spain, sitting in a castle or big stone building with a phone for sharing internet in the window and speaking with Andy. And I was probing him on all the things I could possibly probe him on in Spinnaker. And we decided to start working on Spinnaker and implementing that in the organization. We went with a fairly different approach than many others, I think, because we already did deployments with GARD. One of the biggest places where we had very different solutions was in the bake stage. People were using Packer and using bash scripts or Ansible or Puppet or whatever to create the instances. So we decided to test out the bakery first. So we used Roscoe, and at that time it was Rush as well, to run the bakery as a standalone service. And we created a blacksmith. We named it Blacksmith. And we created a Python client where we had like API to choose base AMI and packages to install. So we launched that actually only a few months later, and it was a great success. Bake times in various teams went down with a lot, and we suddenly started sharing packages. This is some stats on our bakery. This is for this year. So given that we had this blacksmith client, those bakes were not initiated by Spinnaker. It was initiated outside Spinnaker. So we don't have those numbers in our graphs. But as you see, in the beginning of the year, we had less than 400 bakes a week. And now we're up to 1,726 bakes a week. And we get a lot of growth on the bakery usage in Spinnaker. And this really helps the migration because people are using GARD and they're using the bakery. So it's only about creating the pipelines and wiring it together in Spinnaker. So we get a lot of things for free by doing this migration path. Because it's not easy to onboard all teams at once in Spinnaker. It's easier to take it step by step. This actual Spinnaker rollout started in May 2016. We had to spend a lot of time creating the Travis integration because Travis was our CI tool. So prior to to be able to make Spinnaker available to our users, we had to have a Travis integration. So the users were already doing bakes with the bakery and deployments with GARD, and once we have the Travis integration, we could just wire it all together. So this is all deployments done by Spinnaker in Schibsted this year. And we've had a lot of growth, and you might wonder what's happening in March here. But this is when we found the need to have, we call it a canary, but every 15 minutes we deploy to ABS to check that all the systems are okay. So we have alerts in Datadog on uptime on the clusters deployed here. So if the instances has an uptime over 30 minutes, we know something is wrong with Spinnaker, because we are deploying every 15th minute. So we can have one deployment that fails, but if two fails, we get an alert. So this growth is not related to our users, but the rest of the growth is related to users. So delivery team probes. We started doing Kubernetes deployments in May. And we had to split out our production deployment so that we were counting AVS and Kubernetes so we can see how much is used to each platform. That's why the numbers are starting in May. But as you can see here, we have a nice growth in production deployments done by Spinnaker. And this proves that the tool is working. The users or teams we are onboarding is deploying more and more by themselves, and we're onboarding teams every month, and it gives more efficiency in deployments in Schibsted. So we're really happy about these numbers. It's my main motivation is production deployments. It's what I work for, and yeah, I'm happy with this. We rolled out Fiat in February. We rolled it out in December 2016 as well, but we had to revert it. But we finally did it in February, and this was a really big thing for us because that meant Spinnaker could become GA, and also we could onboard payment and identity teams into Spinnaker. So we love this. Finally, we have a complete product. So I'll talk a little bit about the bake service and what kind of experience we have with that. I'll start with the bad things and then move on to the good things. We are running with Artifactory as our package handling system for uploading and indexing OS packages, Debian and Yum repositories. We have a setup where we have local, Debian local or Yum local, where we have all the libraries. This is things like JDKs, like shared packages, Sumologic config, and stuff like that. And ephemeral is where you deploy your applications. So if you have an application, you should always use the ephemeral repository. And in that repository, we only save the OS packages for 7 days. And that makes it kind of consistent in size, and we get more reliable indexing times. And the reason we have this ephemeral is that what we consider deployables are containers, images or AMIs, and libraries, while the application debs or RPNs are not really deployable. They're just there to create a deployable artifact. So we did a big repository backup, and we're paying the price for this. And that is because as the owner of the Artifactory repository, and with all these companies, one of the policies is to share infrastructure. And of course, users with Puppet are using our Debian local repositories. Users with Ansible are using our Debian local repositories and Yum local repositories. And if you've been working with Puppet, for instance, you know that if you have 10 bare metal servers running for a year, they won't fetch that package for a year. But if you get the 11th server, it will fetch all the packages. So you can't really look at Artifactory in any way to know which Debian files or RPMs that are actually in use. And this makes it impossible to clean. So this, we are paying this price a lot. We have to do changes there, but it's not going to be easy because it's involving all our teams need to migrate if we are migrating to new repositories. So this is one of my technical debts, which I'm not in love with. And when we rolled out the bakery, people were using Amazon Linux, they were using Ubuntu, they were using CentOS. And these systems are slightly different in install packages. We have done the decision to support all of this, and that creates kind of crazy install packages scripts. And we're paying the price for that as well. To prove that point, it's like Ubuntu is using Upstart in Trusty, moving to systemd in Xenil. Amazon is using Upstart, and CentOS is using systemd. So you can imagine how our shared packages look like. They support all of these things. So we have the AVS bootstrapping package, which emits the same events if you're building with CentOS, Amazon Linux, Ubuntu Trusty, or Xenil. And then we have the sumo logic config, which just wires up the configuration, fetches secrets and everything, and makes logging work on all the instances. Data config, the same for metrics. And Strongbox is our security tool. But of course, all of these packages needs to cope with all the base OSs. So one big takeaway is to try to limit. If you're advising someone to use Spinnaker, advise them to choose one OS, one version, and not do this, because Bash doesn't look really good when it's in these packages. And we have security teams, and of course we need hardened images for all of these OSs, so they have a lot of hardening to do. And so this is explosion of work to do. So this is something we learn. And now I'm told to stop focusing on the challenges and problems, and I'll tell you a little bit about what's working with the bakery. If you've been doing Packer bakes, like as a noob doing Packer bakes, it takes 12 minutes or 14 minutes to do a bake. And most users are super happy when they migrate to the bakery and they get bake times at 6-7 minutes. But of course, if you optimize your bake, we have 2.5. This is Go applications. If you do a Go application, you can bake in 2.5 minutes. But let's say most of our applications is around 3 minutes and 30 seconds. And yeah, Spinnaker, when we're baking Spinnaker components, it takes between 3 minutes and 30 seconds and 4 minutes. So it's quite fast, and we're really happy about the bakery. We're using CH root bakes. It works really reliable and very good for us. So how we do this is that we create like base AMIs with all the kind of Schibsted conventions built in. So we have distributed logging, we have distributed metrics, and we have Java pre-installed. And then the application itself only installs one RPM or Debian package with only the jar file and the log configuration and metrics configuration for Datadog. And we have a Gradle plugin which does all of this for the developers. So if they're following the main track and creating a new project, this Gradle plugin will successfully make them deploy something with Sumo Logic, Datadog, and Java just working. So stability. So our Roscoe bakery is stable as a rock. We rarely get any errors related to Roscoe itself. Packer has a little bug which hits us every now and then, but it's just to relaunch the bake. So Roscoe in Spinnaker is really good, but Roscoe is kind of dependent on the indexing time of Debian packages and RPMs. And this is why we created the ephemeral repository, but you still have to consider the indexing as eventual consistency, and that's a pain point. In the beginning, people were having sleep 60 prior to doing a bake, and that hurts my heart. So we did a fix for that. So we have in install packages, we have a loop which checks for every package you install. It checks if it's in the index, and then if it's not in the index, it sleeps for 20 seconds and then retries. And this goes on for 10-15 minutes. And this has greatly reduced the amount of support tickets on the bakery. I think we have to do this because if the interface to the bakery was a jar file, you could just have a file reference and download it and put it into it. But as long as you're using Debian and RPM packages, you will have to use up to get the dependencies installed, and that's kind of, it's an Achilles heel of the bakery, which is not inside Spinnaker, but I think Spinnaker, when we are talking with the customers or people that wants to use Spinnaker, it's really important to get them set up the artifact handling in the right way, because it's a pain in the ass if it's not. Yes. If you have any questions or comments about the bakery, please just stop me, because now I'm moving on to deployments.
Okay, yeah. Quick question about the previous AMI that you mentioned.
Yeah.
Did you use Spinnaker to do that too, or is it a separate part?
Yeah. So the base AMIs, the security team, we created a Travis job, a script stage basically, which lets them inject the AMI references into a Dynamo. So when we create the security hardened AMIs, we are actually running a pipeline which then updates the config of Roscoe itself. And then you can reference the Schibsted Amazon Linux, and you get the security hardened AMI every time. And for our applications base AMIs, we are using Spinnaker pipelines to do that, and just referencing that concrete AMI in the bake stage. So for the hardened AMI, users get dynamically updated AMIs, but for custom base AMIs that are ready for your application, you have to reference it by ID. And that's because it explodes when you're closer to the application, because we have some teams using Node, some using Java, some using PHP actually. So we won't support all those flavors. We don't want to do that. And when you multiply that with CentOS, Amazon, and Ubuntu, it's a wide tree.
Yep. So why did you take the approach of putting the check script inside the Roscoe bake? And maybe we ended up having the exact same problem. It takes about 15 minutes for indexing of a new package. I wrote a script to clean it all up, but I think our biggest victory was we didn't complete our pipeline for the creation of the artifact until it was available in our repository. So I was curious why you chose to do it in Packer builds.
Yeah. So with the ephemeral repositories, where you save them for 7 days, Artifactory has incremental indexing, which means that most of our Debian package indexing is done within 600 milliseconds, less than a second. So, like every day, you can do deployments and bakes very well. But then when we have slowness in our factory, it blows up, of course. So it's about being kind of, it's just to not get those support requests, basically.
Okay.
And we put it there. We also have some other batteries included in the bakery, which is the security team, when they do hardening of AMIs, they have to run commands that are not yum installed because they need to run yum or run upt. And we have a script stage, or if you put a key in advanced extended attributes, you can launch a script as root after your package installs. And that's how we do the hardening, because they need to update the kernel, for instance, and there's some stuff. Yeah.
Another question.
Yep.
You mentioned some problems with Packer from time to time. Was that related to true building specifically? Was that something that started when you started using true building, or did that this with the EVS builder too?
So the issue we have with Packer and CH root is if a bake ends on that VM or instance, and it tries to mount the next bake within 5 seconds of the previous one ending, it tries to mount the same mount point on the machine, and it fails. And this is quite, in our case, we have a lot of bakes, but it's not hitting us a lot. So it's when you're testing the bakery, you see this, but in regular usage, you don't normally see it. And so I hope Rob will fix it. I've spoken with Rob about it, and I have hopes now. Any more questions about the bakery? No? Then we'll move on to deployments. I took 3 ways of deployments in Schibsted that I want to go through. We are doing some more, but they are kind of boring, just using Travis stages, and that's hacks, so I didn't want to go through those. So let's look at ABS first. ABS is basically why we chose Spinnaker, because we need a good story for the deployments to ABS. In my opinion, and in the team's opinion, and by the numbers, it's a huge success internally in Schibsted, and it's super easy to migrate from Asgard. It's a good story behind the ABS deployments in Schibsted now, thanks to Spinnaker. One thing we've done, I don't know why actually, but we are using camel case in ELB names, and that gives us some problems. We are basically using a fork of Clouddriver just to support the naming conventions we have. So that's something. But that's the only issue we have with ABS, and that's a very minor detail. So ABS, not much to talk about in this audience about ABS because it just works for us. So it's not very interesting.
Question I saw in your agenda, you mentioned about ECS. So do you deploy to ECS?
Yeah, that's one of the things I dropped because it's just using Terraform in the Travis stage. So it's not much to learn from it. And currently we are migrating them to Kubernetes deployments, that team. So I dropped it. I had some slides on it, but then felt like that's not what I want to share.
Yes, the Lookout team is adding BGS integrations, so they have a talk tomorrow, I think.
Cool. So Kubernetes has been a different experience in Spinnaker. And the reason, in my opinion, that Kubernetes is different is that it is a cluster that we are hosting ourselves. And that means that the same rules as against APIs doesn't apply anymore, because we have a team that maintains Kubernetes, and they upgrade the cluster by creating a new cluster and migrating the customers to a new cluster. And this doesn't work very well with Spinnaker. Spinnaker is kind of used to being connected to an account, which is stable and not just shifting to a new cluster all the time. And this has given us challenges, because if you define the ingress and service objects in the UI, and then we migrate to a new cluster, they're lost and they're not a part of the pipeline. So the requirements to Spinnaker when doing Kubernetes is quite different in Schibsted from ABS. And I tend to look at it as, with ABS, we're deploying applications to existing infrastructure, but with Kubernetes, we are deploying with infrastructure, and that means we are including the ingress and service and config map objects. And given that we need to support the migrations to new clusters as well, the game is kind of changed when we're working with Kubernetes. But there's been some work that has made this quite possible to do. Declarative pipelines, if you have a base template which sets up how you deploy things, you can easily have the base template change from deploying to one cluster to deploying to that cluster, and also the new Kubernetes cluster, so that you deploy in parallel without changing all the applications. And you can do this kind of migrations using declarative pipelines, which this tool gives us great ways of facing these new challenges we are facing in Kubernetes, or with Kubernetes. We've also create support wheels. I was told by a colleague that this is not how you say it in English. It's when you have a bike for a child, you have these wheels on the side.
Training wheels.
Training wheels. So we have created training wheels for ingress, service, and config maps to also support this new challenge, which is that we are basically getting new clouds every time we deploy Kubernetes, and we have to support that. If not, the customers gets really angry, for the users. How we do this? The training wheels, it's our Kubernetes helper. We're using the Webhook stage, the new feature in Spinnaker. And we have a service running within Kubernetes, which accepts Webhook requests, and it updates ingress, config maps, and service objects in Kubernetes. And it's allowed to deploy to the various namespaces because we are using rbac rules. And we're leveraging decorated artifacts. So we filter in the pipelines on Kubernetes objects and just push that payload to the Webhook stage. And we have control over the application itself, or replica sets, with the native integration in Spinnaker. And the rest is taken care of by the Kubernetes helper. So this kind of proves how flexible Spinnaker has become as well, because we have a lacking feature in Spinnaker for config maps, ingress, and service objects, and we can just use the Webhook stage, decorated artifacts, and we've got it covered. And of course, declarative pipelines. This pipeline that does this has a lot of code, but for the end user, when we're using declarative pipelines, they don't see it. It's easy. So, yeah. The PaaS is something we're building in Schibsted. It is a PaaS, but it's really a Kubernetes integration, Schibsted-specific Kubernetes integration, where the whole defaults for the company for doing metrics and logging and monitoring and all these things. And the delivery team in Schibsted has recently adopted the PaaS team, so they're working inside the delivery team now. And it's our integration point, or our future integration point against Kubernetes. We are, of course, using Webhook stage to do this. So we have our own DSL against the PaaS, and we're using the Webhook stage in Spinnaker to upload this to third-party resources in Kubernetes, which is a good way to extend Kubernetes using third-party resources. And with this approach, if a company in Schibsted wants to use Jenkins or whatever to do their deployments, they can still integrate against the PaaS using TPRs, and the PaaS will take over from there. We have a deployment daemon inside Kubernetes, which listens to TPR uploads and does the magic works, taking that schema and converting it to Kubernetes objects and pushing that out. And the deployment daemon then updates the TPR and says that the deployment is done, it's successful, or whatever. And then the Webhook stage waits for this update and reports the status back to Spinnaker. So, any questions about our deployments? I'm heading over to declarative pipelines now. No? Great job, Rob. So we've gotten a shitload of requests about pipelines as code over like 1.5 years, almost immediately after launching Spinnaker internally. And I think, to be honest, that one of the reasons we got all these requests is because the people closest to us is not the developers, but it's infrastructure guys who are setting up applications, and they're doing this a lot, while our end users, the developers who are actually running the pipelines, are further away from us. But we got a lot of noise on this. Some people in Schibsted actually created an internal Spinnaker CLI, which downloads the JSON and uploads the JSON. That's a pain in the ass to support, at least when you're not willing to do it because you're waiting for the declarative pipelines. So we had a lot of internal fights on this. But then declarative pipelines started to mature. We started looking into it in May this year, and it was mind-blowing. The feature set of declarative pipelines is like, if you're blocked by declarative pipelines, you're doing it wrong. So yet again, awesome work designing and implementing this declarative pipelines. So what we are doing is the delivery team has started providing base templates, and that's kind of what we consider the best practices of Schibsted. And we are sharing those base templates with the other teams so that they only need to define stuff that is unique to their service or application. We created a shared script in the CI system, which uploads base templates. So if you do upload YAML, Spinnaker pack, and your file, it will automatically set versions like, I'll actually come back to that later, so I'll just go quickly through this. Yeah, so we have an upload script, shared upload script. We have a proxy in Orca, which just terminates username password authentication against Artifactory, so that we can fetch the templates without credentials. Currently, it's hard for the end users to debug template declarative pipelines because usually it fails with a null pointer in Orca, but we've been told to help out with giving better feedback there. So yeah, I'm sure we'll make that better. One important thing for us is to have pipelines. When the pipelines are defined in code, we want to be able to roll back. And we upload pipeline templates for every CI build so that you can roll back and use the previous version of the pipeline template. And I'll get into how we're doing that here. Here is the upload YAML. Yes. So we have a shared script, upload YAML, which you say, I'm uploading pipeline as code and your file. This results in the GitHub org as one part of the path, then the GitHub project as the next part of the path, and we use the file name. Here it would be main, and then we inject some build numbers from Travis, and it's a unique version every time you run a CI build. And this is decorated with artifact decoration in Igor. So Spinnaker recognizes this as pipelines as code, and we filter in the Spinnaker trigger stage on artifact type and name for the pipelines. This means that one application can upload like 10 pipeline definitions as code, and we can also always roll back by using the pipeline definition relative to that build, which was really important to us. This is up and running and working for us, and we like it. Any questions to this? Yes?
I didn't quite catch it. It seems like the pipeline definitions are by builds, so you can sort of roll back by the individual builds.
Yeah. So we fetch the pipeline config, what template to use from the artifact list in resulting from a CI build, which means when you run with a previous build, you'll fetch that pipeline definition that was relative to that build.
Okay.
So if you mess up the deployments, changing the health check to something that doesn't work or whatever, and you've failed everything, you can just roll back and it will work.
But you can still have cross environment, you can still have cross build common things in the templates. It's just that all the builds that could be rolling back to the previous set of builds. Like you have like say 10 builds, they'll all use a template. They all upgrade, but maybe only one of them breaks, and you could roll back just that one to the previous set of builds. Okay.
You get to a point where not much is changing in the deployment template once the application has kind of gone to production and stabilized. I mean, couldn't it be a dozen deployments with no change?
Yes, I am personally, I'm enthusiastic about declarative pipelines, but I think I'll get back to that later as well. But I think this is about automate all the things, and I don't agree with automate all the things, because if I'm creating an application, I don't care if I spend one day defining the pipeline if I'm deploying this every day for 5 years. Yeah, I think it's really static data. For the Kubernetes deployments, we will actually get a lot for free with this regard, but my heart as a delivery person says that it should be possible to roll back always. So that's why we implemented this way. We want to be able to roll back at all times, but I agree that automating this thing is kind of not the most important thing, because it's really static most of the time, and it's easier to modify the UI than we have a super good user team in London, which is awesome. They've gotten access to the Orca logs to debug declarative pipelines, and they've created this base template, which is using all the batteries included. The services has their own specific overrides, and they're using Travis to run Clouddformation and exposing the stuff like security groups, load balancer, VPCs, everything from Travis as properties. They're actually using that data to their deployment stages. So there are no manual stages involved in creating a new pipeline or a new application, which is kind of showing the power of declarative pipelines combined with all the other features in Spinnaker. So these guys, they've put a lot of effort into it, but it's really sweet to see that they've made it work. So the pipeline we are working on providing is the Kubernetes pipeline from the delivery team. We provide a base template there, and it deploys to dev, pre, and pro. And what we've done is to add the optional after dev, after pre, and after production pipeline stage, which you can reference your own pipeline. And this pipeline that you're referencing can either be defined in the UI or as code. We don't care. But this gives all our users an escape hatch, because usually after dev, after pre, or after pro, you want to run integration tests or crazy stuff or whatever. And when using the pipeline stages embedded in the pipeline, we're able to provide that to the users so they can highly modify their pipelines without having to go out of our base templates. Yes?
So what you're saying there is that your template allows your users to run pipelines before each of the stages. Like they're just additional pipelines that they will define and then trigger. Is that correct?
Yeah, embedded pipelines, like pipelines as a stage in Spinnaker. So it's basically a powerful escape hatch. And this is funny because we got a lot of requests on pipelines as code. And the first team we launched it to, they thought it was really annoying to not be able to use the UI to modify their pipelines, of course. So this gives them the opportunity to modify what's unique to them in the UI and still use the declarative pipelines. Yeah, and we have an optional manual judgment stage there as well. To us, it's super cool with the declarative pipelines to be able to provide base templates and like give you a highway to good deployments in our systems. I think it's really a step up for Spinnaker to do this, to support declarative pipelines. The pipelines within the delivery team itself is a lot simpler than our other users. We have a main pipeline for every project, which we deploy to dev and production. We have a branch testing pipeline for every project. So in every branch, we upload Debian packages and RPMs and pipeline definitions. We have a pipeline which only bakes and deploys to dev, so we can test the branches prior to merging. This is very useful when you have some changes you need to test. We also have deployed to production in a separate pipeline because we are using Spinnaker to maintain the clusters as well. When we roll out changes like enabling or disabling fiat, for instance, we need to make sure all the Spinnaker clusters are fetching the new Dynamo configuration, which is fiat is on or off. And then we're using the same pipelines that we are using for the regular production deployments. And this is, I think, what made me fall in love with Spinnaker was the powerful pipeline orchestration part. This part with child pipelines and embedded pipelines and fan in, fan out is really, I haven't seen that in other systems, and it's super powerful. Okay, I have 4 minutes left and I started early. I have to be quick now. Yeah, I've been through, in Schibsted, Spinnaker is always stable, except when we're upgrading Spinnaker. We have some issues with Clouddriver. We're running 100 AWS accounts and maybe 30, 40 Kubernetes accounts. And this makes Clouddriver slow. But I think Netflix is working a lot with the performance of Clouddriver. Now I'll be sure to probe them a lot on this when I'm here. But I think us using 100 AWS accounts is kind of, it's bad. So I don't blame Spinnaker, I blame the organization. And I was really going through the RPM Debian indexing stuff, which is an Achilles heel. And I think this is, it's outside Spinnaker, but it's so crucial for Spinnaker to have a good package repository that it's worth including it. Yeah, so when our Spinnaker setup is, we create the infrastructure for Spinnaker, the shared like ELBs, the security groups, everything in one repository, Spinnaker config, which also has the accounts for Clouddriver and everything set up. And for every component of Spinnaker, we have Igor config, Echo config, Front 50 config, and everything, which pins us to specific versions of Front 50, Echo, all the components. So we have one layer between us and the releases of Spinnaker. And we're using the metrics stuff. I want to say, Eric, it's a great job on the metrics. We've been using it ever since I was in New York, and super cool dashboards, and it's useful data. Really. So I mentioned this as well on one of the Spinnaker things as well. Spinnaker is getting mature. It's getting more boring for me because I have to help users more than code, and usually Spinnaker has all the things on. Is already there, and I have to just help the users. And we've seen that when we encounter bugs, we start writing a patch. We check upstream first, and then we start writing a patch for Spinnaker. And when we create the PR, we see that there's a matching PR with the same code upstream already. So it's got a lot of traction now, and this has happened several times. So yeah, that's super good. We're seeing that we don't need to have our own forks of Spinnaker anymore. We have forks of Front 50 and Clouddriver, but that's entirely our fault. It's the ELB naming convention stuff we're struggling with, but other than that, we are like vanilla Spinnaker users now. And that was not the case 1 year ago. Then we were unicorns. So onboarding users into Spinnaker, the biggest pain point I have is overengineering, which is people wanting this super advanced pipeline when they have a service that just needs to be deployed. So the discussions are sometimes kind of far away from what they need. And also the automation. So in our company, really a lot of people are very concerned about automation. And what I've learned about automation is that you automate repetitive tasks, and like automating for just automating everything is really not that valuable in many cases. So there's a lot of discussions on automation, which is really not very interesting. Whoa, what happened there? Yeah, it seems I'm This was the thank you slide, so. Yeah. But thank you. Questions? Wow.
How many Spinnaker cluster, if you will, do you have in your company? How many users?
How many Spinnaker fully systems that are running?
Yeah.
Spinnaker, we have 2 testing environments and production. So one system is connected to all our accounts. Yeah. But we are using Fiat to control the authorization to the various accounts and everything.
Are you using multiple cloud driver bases with that many AWS accounts?
So we're using 6 fairly large cloud driver instances for the account syncing, and we have a dedicated cluster with, I think it's 6 instances right now, which Orca and Gate speaks with.
Okay, so those would be like read only?
Yeah, it's not read only, it's actually read write because Orca does the operations, but it's not doing the syncing, which is the heavy lifting.
Do you use ETA for your cloud drivers, or are you just hitting all these guys?
We are hitting it hard. I think this is like a part of me thinks that the cloud driver is the integration against ABS, and I think cloud driver should cope with those things. And when I started doing PRs on that, Cameron had already done the rate limiting stuff and everything. So with the right settings, it kind of works. Oh, yeah. Yes.
How big are your accounts typically in AWS?
Yeah.
Just an idea of how many instances, how many server groups you normally run.
So most of our accounts are really small. That's kind of funny because we started hitting the throttling issues when we had accounts with more than so and so many auth scaling groups and stuff like that. And it's only a few of our accounts that really has a lot of stuff in them. So yeah, there's a lot of small accounts because every team or product that starts in our company gets 3 ABS accounts. They get pre, dev, and pro, and they're basically like our payment solution, of course, has its own, but also small teams has their own accounts. Yeah. Yes.
Question about the scope of adoption. Is this entirely application or like web tier or data tier as well?
So the
systems.
It's mostly all our application, but data teams are doing it as well. But that's more the APIs of the data teams. We don't have like persistent storage teams. I think the Cassandra team is deploying with something else right now. Some custom scripts. We've been discussing it, but they're not doing that. Prometheus is being deployed by Spinnaker, though.
How are you deciding between using images or AMIs versus using Kubernetes for deployment?
Kubernetes is our next step, our evolution. So ABS is kind of the de facto standard, and we just started onboarding people into what we call the CRE, which is actually Kubernetes. So that's a slow migration we're doing next to it.
And the follow-on is, are you trying to consolidate accounts or consolidate applications into your Kubernetes cluster, or are you, because I think you mentioned you have 40 Kubernetes.
Yeah, so every team that's onboarded to Kubernetes gets 3 namespaces. We have only 1 Kubernetes cluster, but a ton of namespaces there. I'm trying to consolidate the accounts into fewer accounts, larger accounts. But then Netflix told me that they were going to more accounts, so I thought it was a good idea to speak with them about the rationale there, because I'm seeing only the pain of doing that, and they're probably seeing the pain of having fewer accounts. So it's complex, and yeah.
Are you doing anything with the content distribution networks, CloudFront and things like that?
Yes, our image service team is doing that. Unfortunately, they are one of our most mature teams, so they fix everything on their own. They're using Spinnaker and everything, but they never ask questions. So I don't know how they're doing it or anything, but they're delivering to one of our biggest sites, the image upload and serving solution. But I have no idea how they're doing it. So yes, we're doing it, but I have no insight. Okay. Thank you.